So over here I have the voltage regulator circuit connected to an external power source, and here is the MOSFET circuit with the pump having the ground connected to pin 2 and power connected to the power rack. And if I plug this in here, this will turn it into a 5 volts, which the 5-volt water pump can use, and the MOSFET will draw power from the external power source when the button gives it a signal, and the pump will just go.
So this is a fault set diagram for my MOSFET circuit. So basically this MOSFET here will take the input voltage from this source right here. And if that is high, it will draw current from the external power source here to turn on the pump. And there's a diode here, so the electrical current from the pump, when it turns off, doesn't damage the MOSFET. This is so that the Arduino Nano, since it doesn't have enough current, it can still control the pump using an external power force.
So here I've added the LCD screen, and it just has these pins to the Arduino nicely lined up to these pins on the LCD, and then there's also 2 over here, and then there's power and ground from over there connected to these pins, and also a potentiometer here to control the brightness. After you got the pin set up, the LCD library basically does everything for you. You just need to use a few simple functions. And if I plug it in right here, I'm just using an example from the library. Just print hello world and a counter. So this is my breadboard prototype for the soil sensors. And here I used these 2 power rails for the I2C bus. The red line is the SCL and the blue line is the SDA. They're connected through the Nano down here. And they're connected to the sensors, the soil sensors that we got here. They're capacitive soil sensors, and they're also connected through power and ground over there. And how this works is that the SDA line will transfer the data between the Nano and the soil sensor, and the SCL line will synchronize the clock so they can communicate correctly. And to use multiple sensors, you need different addresses. So over here on this one, I have soldered the AD0 pad, and over here I haven't. So they now have different addresses, so they can be referred to separately on the I2C in the code.
So this is my breadboard prototype working. As you can see, the LCD screen is displaying the information gone from the soil sensors, and it will switch in between the plants, and if the moisture level gets too low, the water pump will pump water and water the plant.
Here is my final product, and it works exactly the same way as a breadboard prototype. There's 2 terminal blocks here to connect with the sensor, and the 2 terminal blocks here are to connect with the pumps. And there is a hole here, so the power cord can be connected through here. And there is a hole here, so the LCD PCB can connect with the Nano. And there's also this cover where I can just put it right on here, and it covers all the parts, and you can only see the LCD.
Finally, this is all my code for the final product with comments to explain what each section does.